Q8167. Compressor field cleaning on turbine engines is performed primarily in order to A. Prevent engine oil contamination and subsequent engine bearing wear or damage. B. Facilitate flight line inspection of engine inlet and compressor areas for defects or FOL. C. Prevent engine performance degradation, increase fuel costs, and damage or corrosion to gas path surfaces. The correct answer is C. Compressor field cleaning on turbine engines is primarily performed to prevent engine performance degradation, increase fuel costs, and damage or corrosion to gas path surfaces. During operation, turbine engines can accumulate dirt, debris, and contaminants in the compressor section. This buildup can hinder the smooth airflow and reduce the efficiency of the compressor. As a result, the engine may experience decreased performance, increased fuel consumption, and potential damage or corrosion to the gas path surfaces. By conducting compressor field cleaning, these issues can be addressed. Cleaning the compressor helps to remove accumulated dirt and debris, ensuring optimal airflow and preserving the efficiency of the compressor. This, in turn, helps maintain engine performance, reduces fuel costs, and prevents potential damage or corrosion to the gas path surfaces. Q8168 hot section inspections for many modern turbine engines are required. A. Only at engine overhaul. B. Only when an over-temperature or overspeed has occurred. C. On a time or cycle basis. The correct answer is C. Hot section inspections involve inspecting and assessing the components in the high-temperature areas of the engine, such as the turbine section. These areas experience significant thermal and mechanical stresses during operation and are prone to wear, degradation, and potential damage. By conducting hot section inspections on a regular basis, potential issues can be identified and addressed before they escalate into more significant problems. It allows for the detection of any signs of damage, deterioration, or abnormal wear in critical components, such as turbine blades or vanes. Performing hot section inspections based on time or cycle intervals helps ensure the continued airworthiness and reliability of the turbine engine. It allows for proactive maintenance and helps prevent the occurrence of unexpected failures or performance degradations. Q8169. A purpose of the shrouds on the turbine blades of an axial-flow engine is to A. Reduce vibration. B. Increase tip speed. C. Reduce air entrance. The correct answer is A. A purpose of the shrouds on the turbine blades of an axial-flow engine is to reduce vibration. Shrouds are the structures that enclose the tips of the turbine blades in an axial-flow engine. They are typically made of a separate material or have a protective coating on the blade tips. The main function of the shrouds is to provide structural support and reduce vibration in the turbine blades. During operation, turbine blades experience significant mechanical forces and vibrations due to high rotational speeds and aerodynamic loads. These vibrations can lead to fatigue, stress, and potential failures in the blades. The shrouds help mitigate these vibrations by providing additional support and stiffness to the blades, reducing their susceptibility to vibrational modes. By reducing vibration, the shrouds contribute to the overall integrity and longevity of the turbine blades. They help ensure that the blades operate within their designed limits and minimize the risk of fatigue-related failures. Q8170. In a dual axial flow compressor, the first stage turbine drives A. N2 compressor. B. NI compressor. C. Low-pressure compressor. The correct answer is A. In a dual axial flow compressor, the first stage turbine drives the N2 compressor. The dual axial flow compressor configuration consists of two sets of compressor stages driven by separate turbines. The first stage turbine, often referred to as the high-pressure turbine, HPT, is located downstream of the combustion chamber and is responsible for driving the high-pressure compressor, N2 compressor. The N2 compressor, or high-pressure compressor, is typically responsible for compressing air at a higher pressure ratio compared to the low-pressure compressor, N1 compressor. It delivers the compressed air to the combustion chamber for the combustion process and subsequent expansion through the turbines. By driving the N2 compressor, the first-stage turbine ensures that sufficient compressed air is delivered to the combustion chamber to maintain the combustion process and provide power for the engine. The N2 compressor plays a crucial role in delivering air to other engine components, such as the low-pressure compressor, combustor, and high-pressure turbine. 8171. What should be done initially if a turbine engine catches fire when starting? A. Turn off the fuel and continue engine rotation within the starter. B. Continue engine start rotation and discharge a fire extinguisher into the intake. C. Continue stalling attempt in order to blow out the fire. The correct answer is A. If a turbine engine catches fire during starting, the initial action that should be taken is to turn off the fuel and continue engine rotation with the starter. When a fire occurs during engine start, it is crucial to cut off the fuel supply to the engine immediately. This helps prevent the fire from being fueled further and reduces the risk of a more severe fire or explosion. Continuing engine rotation with the starter serves two purposes. First, it allows the engine to continue turning, which can help cool down the affected area and reduce the intensity of the fire. Second, it aids in blowing out any flames or excessive fuel that may be present in the combustion chamber.